Hello, everybody. I'm Cédric Bellanger from Marketing Communication Department at OPTIS, and today I'm very pleased to co-present with Gilles Gallet.
Good morning, Cédric, and good morning, everybody.
So today the topic is the virtual testing of autonomous driving systems. First, a few words about OPTIS, world-leading company in virtual prototyping, provide simulation software allowing you to accurately simulate the performances of light, of human and sensor vision, and material interaction, ultimately allowing you to experience your product virtually before it ever spending time and money to build multiple physical prototypes. So thanks to OPTIS, you imagine, design, and virtually see and hear what you will get during all the stages of the design, engineering, and manufacturing process. Automotive innovation has been a passion and the main industry focus for OPTIS for more than 25 years. I will start briefly with the challenges. Then Gilles will develop what we do for the sensor vision, develop some customer cases, and speak about the early adopter program. Let's start with the challenges. So the revolution, okay. The autonomous driving will of course bring a revolution. First, it will bring safety. Avoid the drowsiness, the drunk driving incident that should decrease because there is no designated driver needed when the car drives by itself. Comfort, of course, you don't have to be stressed by the circulation. The car is dealing with all of that. More important, the time. When a computer takes over the driving responsibilities, driver can use that time to do other things, like catch up on reading, for example. Also, self-driving cars in large number of participates in a behavior known as platooning, which would significantly improve the traffic conditions and congestions. And sensor also in the autonomous cars allow vehicles to ride closer together, therefore allowing more cars on the road with actually less traffic. And also very important, mobility for everyone. Disabled individuals who have to rely on public transportation or assistance from others to get around could reap the benefits of self-driving cars with new freedom and enhanced mobility. Even dogs can have their own mobility. What's new regarding the automotive? If we consider the driver, the environment, and the vehicle first, what is new is the new HMI. Improve the interaction of the driver with the environment with augmented reality head-up display, for example. Change the interaction between driver and vehicle to deal with handover driver driving to autonomous driving. Entertain or inform the driver when he's not driving. And the other big news is also the car vision. Develop the interactions between the vehicle and the environment. Develop the vision that the car has of its environment through optical camera, radar, lidar, Li-Fi, and ultrasound. OPTIS, yes, today we address both topics, but today we are going to focus on the sensor vision. Okay, what are the challenge of the sensor vision? The French industry and technology magazines report the different traps for sensor vision. First, the different reflection from the buildings, the other vehicles, the markings that are different depending on the states, on the countries, marking that differs by their quality. Shadows, here due to a traffic light pole, for example. Inspection holes with their slabs of metal, surfacing of the asphalt. Weather conditions, traffic lights, different depending on the countries. Traffic light with lighting that are different in color and intensity. The major traps are linked to light, weather, and materials. Today, it is estimated the big challenge regarding all these traps is to replay these situations. Today, it is estimated that for one ADAS, the distance to validate one ADAS is around 1 million miles for a cost of $5 per miles, and a time from 6 to 12 months. It is also estimated that autonomous driving systems represent more than 25 ADAS systems. So that would be a distance of 200 million miles to validate properly the autonomous driving. So that makes it quite clear that the only solution, economical solution, a valid economical solution, is the virtual testing. That's our proposal, and I will let Gilles Gallet do the development of this explanation.
Yes, that's clearly a high challenge to reach such kind of virtual testing and validation. So, and what is clear is simulation and virtual testing is key to achieve such kind of validations. And part of this virtual testing, the sensors part is also a key challenge to achieve. So that's where OPTIS is acting, and with ADAS and autonomous driving, there is now a shared control between the driver and automation. And this is the cohabitation of these two workflows, which is important to take into account, and that's what the OPTIS virtual testing platform is putting together. On one side, the driver, the vehicle, and on the other side, the environment. So the two workflows are able to achieve the system and the embedded intelligent systems, and also the HMI, which are all based on physics-based modeling. And for the sensors, in particular the optical sensors, it's mandatory to get precise and accurate models during the simulation process. And also for the environment, it's also mandatory, and the OPTIS solution provide the lighting conditions perfectly reproduced, as well as the other vehicles and pedestrians, in order to put the simulation in the context. So to address this challenge, the proposal is physics-based modeling, and physically correct content definition is key, from a fully modeled light source, the path, and through an optical characterization of the materials, the surfaces, and the volumes, up to use the sensors as well as the human eye and digital cameras as a receiver. And the physics-based simulations is the only way to guarantee the predictivity and the realism of the simulation. The OPTIS simulation platform is CAD integrated and system development, and it also connected to the system development tools. So it's a cooperative platform, and this solution fits to all the automotive industry challenges. Now let's start with in-vehicle modelization to illustrate that vision. And before going in the detail of the sensor, keep in mind that the human factors, and especially the human vision, represent 85% of our perception. And light simulation is a major topic to solve the visual challenges of the HMI, as for example the veiling layer, but also all reflections in the car, and as well as the screen washout on the HMI, and legibility and readability, which are key to assess the HMI in terms of visual perception and human ergonomy. Now let's go outside of the car, and one of the key points is to well handle the driver vision as well, and in that point lighting is also very important. So the challenge of new intelligent lighting system, which are the new concept of ADAS headlamp, ADAS lighting, which are increasing a lot the driver vision by night. Such kind of ADAS are highly complex. It's a link between the lightings, hundreds of LEDs, the ECU, and the camera systems into an automatic system, which are complex to set up, to test, and to validate. So the OPTIS solution is basically looks like a driving sim, but in fact it's a complete virtual test bench connecting the system simulation with the lighting simulation. and this is what you have in the video. And of course, such kind of application is now fully integrated into the automotive process, and it's on the way to reach the numerical certification of the intelligent lighting system. And of course, if we are going further to the camera, it's the same approach. In fact, the camera is stimulated by light, and a lighting simulation is mandatory to simulate very accurately a camera sensors. And on this video you can basically see and illustrate how important is a simulation on a camera. And for example, you can clearly see that the sky is clearly at the same level of luminance compared to the trailer. And for that, it's only because you have the simulation and you have the luminance that you can precisely identify such kind of issue. So again, the challenge is to master the camera using the OPTIS simulation platform. Now let's go on to customer use cases. So one for the camera and the second one on the LiDAR. So basically for each use case we have the same process. So behind the OPTIS solutions platform you have a process how to implement and how to use the sensor simulation. So first step is to optimize the sensor positioning. Second step is to test and validate the sensor positioning and vision using open loop simulation. And the third stages is to test and validate your ADAS system in a closed loop simulation with your camera model. So let's go in more detail now. So start with the CAD geometry. So you are in your CAD platform, you define your geometry for the car and as well as for the environment. So the objective of that part is to well identify your geometry environment in terms of cars, shape, and of course in terms of road scene and other objects that can be easily added as a target or as a reference or as a blocking object. Second step is to set up the materials and the optical properties of your geometry in the CAD model. So you have to define the optical properties for the roads environment, for the car, and also for the target, as for example here in a case on a Euro NCAP AEB test, it's important to have the dummy with the correct optical properties of the clauses, and these are also available. So these optical properties are available on the OPTIS library, available through OPTIS software. So it's possible to get these materials from the library, or for any new kind of material it's possible to measure the material with the OPTIS devices. Then it's important to define the camera model and to define it precisely. So it's possible to define the characteristics of the camera in terms of field of view, image size and pixels, lens distortions, lens transmittance, imager sensitivity, white balance, gamma corrections, and also more advanced optical properties that takes all spectral information into account. So using these camera locations provided, it's important to precisely position the cameras on the car, or in that case on the roof of the vehicle. After setting the camera locations, so the simulation environment is ready for evaluation, and it's possible to generate grid of pixels in order to evaluate the performance or vision of your cameras, and for all of them, for each of them. And in addition of the initial field of view analysis, the projected pixel grid is also helpful to check things like the camera overlap, for example. So at this stage, it's also easy to quickly check influence of mechanical tolerance and variations in the camera vision performance. At this stage, it's also possible to take into the consideration the light sources, as for instance, here we consider the sun positioning relative to the car, and the driving condition with road object, pedestrian cars, which can be considered as target or view blockers, but also the light conditions, so by daytime, but even by nighttime with street lights, headlamps can be set up to define the context of the simulation. So from this various situation setup, image generations enables to check the vision performance, the detection or the basic detection, in order to evaluate the influence of various parameters. It can be considered as preliminary testing prior to more intensive testing. So that's what we are calling offline simulation or open loop simulation. So after that, it's possible to generate some videos. So here, for example, we have a very quick and video generation. On the middle, you can see the car positioning with the grid, showing the vision covering from the cameras. And you can see the 5 camera vision. And then it's possible to go one by one and evaluate for each camera, generate the raw data of the camera directly, and also because behind this image we have the simulation, so it's also possible to generate the radiance and the luminance map of the camera vision, which make that tool a complete lab to evaluate and really evaluate the content of the camera simulation. Another example based on a video. So now we have defined and we have been working on the camera evaluation, vision performance, considering the car body. It's also important now to bring that model and all parameters into a context of system development. So in terms of closed loop simulation, so bringing a more accurate environment with vehicle dynamics, with ADAS, self-driving car software, with the accurate model, and then making simulations and simulations again with various parameters, various contexts, with traffic, pedestrians, and of course here we have 2 examples on the left at 12 p.m. and on the right with the sunset. So it's 2 contexts, 2 variables on the same scenarios. And we can go on. So another case is, now let's talk about the LiDAR. So LiDAR is an optical sensors, so same approach, same process. At first optimization of sensor positioning, then validation through open loop simulation, and then bring the model into a closed loop simulation for system development. The LiDAR technology now is getting more and more accurate and more accessible in terms of price for the automotive industry. So it's now a clear technology for the automotive market. And the LiDAR is like a camera with a beamer. So you have a beamer in the laser bandwidth and a camera with a certain resolution to capture the distance. and the object. So thank you to LiDAR for this short introduction and showing how the LiDAR technology will be tomorrow one of the key sensors of the autonomous driving cars. So same as for a camera, first step is to come into OPTIS solution software, define the LiDAR and the sensor characteristics, define the car geometry, define the target, and then evaluate the vision performance of the LiDAR according to the positioning on the car body. And at second step, generate that camera vision, the LiDAR vision, in order to well identify the influence of the positioning of the LiDAR or the characteristic of the LiDAR, how it influences the sensor vision. So that can be done directly into the CAD. And same at third stage, it's same as for a camera. It's possible to bring that LiDAR model into a complete driving simulation environment in closed loop simulation. So here in that case it's a Velodyne model which has been put on the roof of the vehicle, and the vehicle is connected to vehicle dynamics, and the vehicle is immersed into an accurate 3D environment. So the OPTIS simulation platform in that case generates exactly what the LiDAR is capturing as in terms of raw data. So as a summary, when we are talking about virtual testing, OPTIS provides an ADAS simulation platform that includes physics-based sensor models as a solution to support the major automotive players in the challenge of AD. So technically, it's first a solution, a product called SPEOS DVS, which is CAD integrated with the objectives to quickly and efficiently evaluate the vision performance and validate the vision performance of your sensors, and then to generate open loop simulation, very accurate lighting simulation and sensor simulation. And at second stage, it's possible to link these models, since sensor, into VRX, VRX AD, which is integrated to the system development with the objective to test and validate the sensors with the systems of the self-driving car. So it's well integrated into a mill, seal and hill closed loop simulation for testing and validate the system part of the vehicle. And to well accompany the deployment properly and efficiently, OPTIS is putting in place now an early adopter program dedicated to strategic and long-term partnership in ADAS sensors simulation. So the simulation platform will include the four main sensors: the camera, the radar, the LiDAR, and the ultrasonic, with multi-level of modeling to balance the performance and accuracy in connection with the third-party tools. So an OPTIS will welcome new ones into that early adopter program.
Thank you very much, Gilles, for this very interesting presentation. As you can see, OPTIS has a global worldwide presence for a local understanding. So I incite you to contact your local dealer or contact me directly to know more about the early adopter program, especially, and to know more about OPTIS product. We will stay connected. If you have any question, I wanted also to just precise that all the videos are very fluid but due to the GoToWebinar connection, it's not appearing as fluid as it is in reality. So so check the website to check this video and have a real understanding of the real time testing. So we stay connected. If you have any question, we'll stay any more minutes. Thank you very much. Have a brilliant day.